Okay, let's try number 5. Day 5, alchemical reduction. You've managed to sneak into the prototype suit manufacturing lab. The elves are in decent progress, but are still struggling with the suit's size reduction capabilities. While the very latest in 1518 alchemical technology might have solved their problem eventually, you can do better. You can scan the chemical composition of the suit's material and discover that it is formed. Well, you scan the chemical composition of the suit's material and discover that it is formed by extremely long polymers, one of which is available as your puzzle input. The polymer is formed by smaller units which, when triggered, react together such that two adjacent units of the same type and opposite polarity are destroyed. Units types are represented by letters. Units polarity is represented by capitalization. For instance, lowercase r and uppercase r are units of the same type but opposite polarity, whereas lowercase r and lowercase s are entirely different types that do not react. For example, in this, lowercase a and uppercase a react, leaving nothing behind. In this, lowercase b, uppercase b destroys itself, leaving uppercase a and leaving lowercase a and uppercase a. As above, this destroys itself, leaving nothing. In this, no two adjacent units are of the same type, and so nothing happens. In this, even though lowercase a, and uppercase a are of the same type, their polarities match, and so nothing happens. Now consider a larger example. The first lowercase c, uppercase c is removed. This creates uppercase c and lowercase a, which is removed. Then either lowercase c, uppercase c, or uppercase c and lowercase c are removed. The result is the same. Finally, no further action taken. After all possible reactions, the resulting polymer contains 10 units. How many units remain after fully reacting the polymer you scanned? Note, in this puzzle and others, the input is large. If you copy and paste your input, make sure you get the whole thing. And we are recording. Let's see. Okay, so we got some polymers. It's a polymer. It's a very long polymer. Polymer. So let's get the input. I hope the whole thing fits in buffer, but they sort of made me paranoid. And so this is the input. I think it's fairly straightforward. I'm a little bit paranoid that that is the whole input after that one, but I guess we can count it. And it's 50,000 characters long, maybe including a new line. So let's see. We are in Advent of Code day 5. Let's go ahead and make a solution.py. And maybe let's start reading it I think because the way Python is, I think I'm going to be developing this mostly using the real estate from top to bottom. So I think knowing that how the previous solution's been very, very tall, and I do like to have the REPL open, I'm going to opt for a sort of vertical split. If I could remember how to split correctly. Oh, I must not be in Tmux, huh? Okay, great. Because I really like having it having the language thing over here, the REPL. And so here, well, the first order of business is reading in that file, right? So I actually have lost track of my previous solutions, so I'm going to do this from scratch. Well, to do is do the file name and then open, really. So, and then input, and then do something with the input, right? Just read it. Hopefully tomorrow I'll have this sorted out. So we just open, and I know that I called it input.txt. I think all we do with it is, let's see, all we do is open and then read. So I think Plumber is going to equal the results of doing that, and then read. And we can sort of quickly do a sanity check on that. And that looks right. And there seems to be a carriage return at the end, so we might get rid of that. I think the built-in length character can be used like this. So if we were to maybe drop that last one, is there a strip in the standard library? String strip. Turn a copy of the string with leading and trailing characters removed. If I were to strip that last character, yeah. So we probably want to do that. And then, so Polymer now is the input. And so we're going to do probably just a greedy search, a greedy linear search. Any of the adjacent characters do this, because even in this situation where there might be some ambiguity in incidents, like which ones do you eliminate first, which pair do you eliminate, the result is the same. Like if you remove the left pair or the right pair, you're still going to end up with a C in the middle. And if there are more adjacent matches, then a linear greedy search should handle this just fine. So we have a Polymer, which is a string, and then basically for char, And I'm not sure if car is reserved in Python. Let's go with car for now then. For car in Polymer, I want to print car. And I enjoy having REPL, and I also enjoy being able to just execute the solution. And that seems to have executed and printed array character, uppercase O, lowercase c, uppercase c. So these seem to match here. Cool. So we are able to linearly choose the input just fine. And let's see, basically for character Polymer, maybe we do want to sort of traverse this with an I, sort of like with the actual index into the string, because this sort of format sort of is very much like element centric, in the sense that you're not really meant to peek ahead near to at the adjacent elements using this for, as far as I know. It's more traditional to instead do for I in X range, perhaps the length of the string, and then inside you can sort of index into the string and traverse that way. I think that's more typical. Yeah, I get hazy on this. I think X range was a Python 2 thing, and you're meant to just range, I guess, in Python 3. And so this would be equivalent. This would be equivalent. Yeah, that does the same thing, except that we have the convenience of being able to say I plus 1 to look at the next item. And so for I in range, we could subtract 1 here. And that way the logic inside is going to be comparing the current element and the next element. And so then if we just go from 0 to the length minus 1, then there's no risk that we're going to peek over and get an out of range error. And so we have one item, and then we want to sort of, compare it to the next item. And the logic is such that if they are the same character, well, if they're the same letter but different case, then eliminate them. There may be some issues though with sort of flipping over it. This because I want to mutate the thing you're looping over, and that might be an issue. But let's try to see what happens. Looping over Polymer, but then Polymer is changing. If you mutate it, that might be an issue. So let's say what would happen if the first item and the second item were to be destroyed. And so I'm writing this off. If the first item and the second item were destroyed, that's 0, 1, and 2. We would want to continue at index 2. But index 2, if you were to actually just mutate the string, you would want to well, if you did actually destroy them, I'm not sure. I think if you do the solution, that a naive solution would just create a new string and then just naively start ranging over it again. But in either case, let me make a helper that can do this logic for destroy, which takes 2 characters, and if a dot, I think 2 lower, in JavaScript it's 2 lower, string lower, return a copy of the string of all cases compared to lowercase. So a dot lower is equal to b dot lower. They're the same character. And I wonder if there's a uppercase Boolean thing, case, swap case. Title case, upper, zfo, capitalize, is lower. Okay, interesting. So then we can just and well, okay, maybe it's cleaner in a different thing. So if there's the same letter, we want to sort of figure out there's different cases. So A is lower. And B and not B is lower. We want to do sort of like an if this is true, or a dot is upper, this is lowercase, and not b dot is upper, return true. And I need some sanity checks. So A is this, and B is this. And so A dot lower is that, B dot lower is that. There would be this, and then A dot is lower is true. B dot is lower is false. So A dot is lower and not B dot is lower. Hopefully this returns true. Or A dot is upper and not B dot is upper. And I'm hoping that the and nots bind more tightly than the or. What are some other ones? If A were this and B were this, then I'm hoping that this also is true. So that's my helper. And so then I can sort of query and be like, destroy P. Should I destroy P? Or rather, should I destroy these two characters? That might return true. So if this is true, it's tricky. I want to maybe, so let's just do it the naive way. And that would be to, I think, slice or sub. Slice. Right. So we could index into a string. So if a string is called ABCD and we wanted to remove the items in the middle, we could do something like well, you could do something like everything up to 1 plus everything from that to the end. And I think we would want to sort of, yeah, okay, so we could do something like that. For I in blah. For I in Polymer, so for every character in Polymer, we want to loop over it. If there is a match, we want to sort of update Polymer to equal Polymer. So we are successively like whittling down the input. And we're gonna index some, so like 0, 1. Right, if we wanted to get rid of I and I plus 1, and let's say hypothetically that's 1, 2, we would do this plus Polymer to I plus 1. Right, if I was 1, then we'd want to add 2, I think. And I think we would break. And we could also define that whole thing as a reusable function. So def find comb string will do this. Find com string will iterate, will traverse the string from beginning to end, from the beginning until it reaches such a match. It will then update the input, find com string, break, return. We can make like a result set. And I could return the result. And that would be one sort of destruction I would want to then well, so for I in range, what if destroy P, let's try to get result is equal to that. So that's destruction. That's one match. We break out, return that. And then you sort of want to run this again. Really, you want to run it while find comb of polymer. And I'm not sure how to structure this. That could be an infinite loop, right? So remainder is equal to polymer. And then find com remainder will return a match. And I want to do something like remainder is equal to the result of that. And for I in range, maybe I'm overthinking it. So for this first element, we test if they should be destroyed. Then we do destroy it. I'm just concerned about mutating the thing you're traversing over in place. Right. Then while I is less than the length of polymer, I want you to basically def so for I in range, Length of polymer -1. Destroy polymer I+1. I want you to break. I really do want you to do that over and over again. So that really should be a function. And now you can return true, so they did make a destruction. Otherwise, return false. And then, while this is true, right? This is line 9. Local variable polymer reference before assignment. Well, this could be stateful. I want to sort of make a distinction here. So it's crunching away. It'd be great if I could just get like a sanity check on it. And maybe this is input 2. For which this smaller input works. And doesn't have an infinite loop. Sixteen. And so find combination. It should find a combination. For I in range, blah. If there's a thing. Return true. Else none, and that should be falsy. New polymer. Invalid syntax. I thought that was valid. Python f strings. Yeah. Oh, you need double quotes. God, these sites these days, man. Return f string. Come on, man. What's wrong with the syntax? Line 10. Oh. Need to specify Python 3. New polymer, DA, PA. Yeah, I'm hoping to mutate that. But it's not. Right, so polymer is passed in a string. DA, BA. That's not right. Oh, that's very wrong. You need a thing there. return true or false. And yeah, I wanted to basically, like, while that performs a destruction, maybe it should return the new one. Okay, that worked. Just don't know how efficient it is. Works on a small input. See if it works on the big input. I probably should have had it print out like that. But hopefully I get a number in 5 minutes, and hopefully it is the correct length. How are we doing on time? 2 minutes. Yep. I think I'm gonna... Hopefully it's the right answer. And if it is, I'm gonna call it there. Remember, the point of the exercise is to practice and just get really, really comfortable, really internalize the language. Like being able to do this stuff in your sleep. It shouldn't be super duper hard. So this basically does a linear search from beginning to until it finds a match and returns a new version of it. And then while there's a new match, it's pretty naive. It does the work twice. So I'm not so proud of it. I'm just trying to get the answer. How would you make more efficient? So find combination, finds a combination if there is one, and ends the string without the combination. So find combination. But when I did while, it wouldn't actually pass. It wouldn't actually... well... You could have had maybe a temporary variable that is a result of it. And then while that temporary variable is true, update the value of the string. Maybe like a do while. While frontier do blah. While blah. While blah. Do while. While loops like the for are used for repeating sections of code. Unlike a for loop, the while loop will not run n times, but until a defined condition is no longer met. Yeah, always run this until no more combinations are found. If the condition is initially false, the loop body will not get at all. As for the for loop in Python, is so powerful, while is rarely used, except in cases where it uses infinite. For example, raw input. Hello. However, the problem with the above code is that it's wasteful. In fact, what you will see a lot in Python is the following. As you can see, this can put the whole thing into a piece of code managed entirely by the while loop. Having true as a condition ensures that the code runs until broken. Oh, maybe I could have done it that way. I wonder if it that way. That's the right answer. I got 1 gold star. And let's just briefly read part 2. But I don't think I'm going to do it. Time to improve the polymer. One of the unit types is causing problems. It's preventing the polymer from collapsing as much as it should. Your goal is to figure out which unit type is causing the most problems. Remove all instances of it, regardless of polarity. React the remaining polymer and measure its length. For example, again, using the polymer law from above, remove all uppercase A units produce. Removing all these units produces that. Fully reacting this polymer produces that, which is length 6. Removing all B units produces that. Fully reacting this polymer produces that, which is length 8. Oh, interesting, okay. In this example, removing all C units was best, producing the answer 4. What is the length of the shortest polymer produced by removing all units of exactly one type and fully reacting the result? Okay, and so I think, so then we would be computing this thing probably 4 more times, so you would really want to do this more efficiently. Just for kicks, I think you would do something like this, and then polymer is equal. So presumably there's going to be at least one combination. If the thing is, so fundamentally this executing this function performs some sort of computation, and if find combination is true, you need to run it at least once to get an answer. And you could update that once, and that would well, doesn't this do that too. And then it breaks. Find combination string. And if it does find a match, it'll break and update polymer. You could do something like return that find combination. And you could do something like new polymer is equal to find comp polymer. If polymer not new polymer, I think you do is not. Then polymer is equal to new polymer. And maybe you could do while polymer is not new polymer. Polymer is equal to new polymer. And then repeat, iterate. And I wonder if I can get this for a small case. None type has no length. Oh. Find combination might be none. Okay, so the first time new polymer is smaller. And then while they're different, we can update polymer. And then new polymer is equal to find combination block. And really it's while new polymer because it might be none. While there's a new polymer. Okay, I think that would be the more efficient way because I think you do the comparison only once. Or you go through you compute it only once. Okay, well that's it. It's kind of late. Merry Christmas. That was Advent of Code, episode 5. Have a great night.